Welcome to The Explainer. You hear the term machine learning thrown around everywhere, but what does it actually mean when a machine learns? Today, we're going to go beyond the buzzwords and give you a clear, guided tour of how this stuff really works and how it's already changing our world. So here's the game plan. We'll start with the core idea of what learning even is for a computer. Then we'll explore the three main ways they do it, with a teacher, kind of like a detective, and through good old trial and error. And finally, we'll see why any of this matters out in the real world. Okay, let's dive right in. When we say a machine learns, it's really important to know we're not talking about consciousness or feelings or anything like that. We're talking about a very specific and, well, measurable process. At its heart, machine learning really boils down to just one thing: getting better at a task through experience. And that's the key difference from regular programming, right? Instead of a person writing rules for every single possible outcome, we create systems that can learn the rules for themselves. A classic way to frame this comes straight from computer science, and it uses these three components. First, there's the task, the actual job we want done. Then there's the experience, which is just all the data it gets to learn from. And finally, there's a performance measure, to score how well it's doing. If its performance on that task gets better with more experience, then congratulations, it's learning. Let's make this real with a self-driving car. The task is to drive on a highway. The experience is watching a human driver for thousands of hours. And the performance? Well, that could be the average distance it travels before a human needs to jump in and take over. The more it observes, the better it drives. All right, let's move on to our first major learning style: supervised learning. The name is just perfect because it's exactly like a student learning something with a teacher who's got an answer key for every single question. The key here is labeled data. This just means every piece of information the machine studies comes with the correct answer already attached. The whole goal is to learn the underlying pattern so well that it can start predicting the right answer for new, unlabeled data it's never seen before. So, supervised learning usually tackles two kinds of problems. On one hand, you've got classification, which is all about sorting things into groups, like deciding if an email is spam or not spam. On the other hand, you have regression, which is all about predicting a specific number, like what the price of this house will be. Here's a classic example of classification. The machine is fed all this patient data, where every single record is already labeled as either high risk or low risk. It learns the relationship between things like blood pressure, age, and that final risk label. And eventually, it can look at a new patient's data and classify their risk level all by itself. And now for regression. Instead of sorting things into a category, the goal here is to predict a precise number, in this case, the price. By analyzing how age and mileage relate to price in a whole bunch of past sales, the model can estimate a value for a car it has never laid eyes on before. So what happens when there's no answer key? That brings us to unsupervised learning. Here, the machine gets a big old pile of unlabeled data and basically has to find interesting structures all by itself. It's acting like a detective, searching for hidden clues in the chaos. The most common job here is something called clustering. The algorithm sifts through the data and groups similar items together. Now, it doesn't know what the groups are called or what they mean. It just knows that the items inside each group share some common traits. So how does a machine find these hidden groups? Well, a common method starts by making a few random guesses for where the centers of these groups might be. Then it does this little two-step dance over and over again. First, assign every data point to its closest center. Second, update the position of that center based on the new group. It just keeps doing this until the groups settle down and the underlying structure just emerges. All right, our final approach is completely different. Welcome to reinforcement learning. This is all about learning from trial and error. And honestly, the best analogy is training a pet with treats. Yeah, this quote just captures the idea perfectly. You can't tell a dog what to do, you can't give it a manual, but you can reward it when it does the right thing and, well, penalize it when it does the wrong thing. It learns from that feedback. That's the essence of this. This all works through a really powerful feedback loop.
The agent, our program, takes an action. The environment gives it a reward or a penalty. And based on that feedback, the agent adjusts its strategy, always trying to figure out how to get the most rewards possible over the long run.
So there you have it. 3 fundamentally different ways for a machine to learn. Supervised, using labeled data like a student with an answer key. Unsupervised, finding patterns in unlabeled data like a detective. And reinforcement, learning from feedback through trial and error. Each one is a unique tool for a unique kind of problem.
So now that we understand the theory, let's look at where this is actually making an impact. Because the truth is, machine learning isn't some far-off future thing. It's already all around us. Think about your favorite streaming service or shopping site. Every time it recommends something, that's machine learning in action. It's likely using unsupervised learning to cluster you with other similar users, and supervised learning to classify which products you're most likely to actually click on.
In finance, algorithms are constantly monitoring transactions, looking for signs of trouble. Using supervised learning, they're trained on millions of examples to classify which transactions look normal for you and which ones are potential fraud, protecting your accounts in real time.
And the impact in medicine is just profound. Models trained on thousands of medical images, like X-rays or pathology slides, can learn to identify patterns that are practically invisible to the human eye, helping doctors spot signs of disease like cancer earlier and more accurately.
And finally, let's go back to our self-driving car. Reinforcement learning is a key technology here. It's what allows cars to learn how to navigate really complex and unpredictable road conditions safely, not from a textbook, but through millions of simulated trial and error runs. So, the big takeaway from all of this? Machine learning isn't a single magic bullet. It's a powerful and diverse field. Whether it's learning from a teacher, acting like a detective, or learning by trial and error, each approach gives us a totally unique tool to solve a different kind of problem. And this leaves us with a final thought to ponder. As these systems get better and better at finding patterns in our data, in our behavior, and in our world, in a way, they're just holding up a mirror. What will they show us about ourselves that we never saw before?